The first thing I'm going to do is set up for the experiment. We're going to need to set this up twice, pretty much exactly the same, because we're doing two conditions. One with the tray flat, and the other one where the tray will be on an angle like that. So we'll start with it flat. I'm going to put in 3 rocks, about the size of a golf ball. These are close enough, because we'll be using the same size ones each time. And then 15 pebbles. Pebbles, not pedals, pebbles. 1, 2, 3. Put them in lots of different places. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, finishing with this little sedimentary one just here. I'm going to get rid of the rest of my pebbles so that I use the same pebbles and rocks each time. Because we want to try to keep all of our variables, all of the things that we could change, the same except for the one thing, and that's the angle of the tray. The next thing I need to put in is 1 cup of dry sand. Now the problem I have is I actually don't have a cup. I have got measurements in milliliters. So what I need to know is how many milliliters there are in a cup. Fortunately, I have Siri. Hey Siri, how many milliliters are there in a cup?
1 cup is 236.59 milliliters.
Right, let's see how close we can get to that. So, I'm seeing between 200 and 400. So I'm going to go for the closest, which is 200. So I'm going to go for 200 mils of sand. I've got sand over here. Whoops, I won't put it near my phone, that'd be a bit silly. So 200 mils of dry sand. Put some in, I'm going to give it a shake. Put some in. Oh look, there's lots of other rubbish in there. Maybe I need to take notice of that. Let me see, how close are we? I think that's about as close as I'm going to get. Crush these up a bit just to check. Don't want to squash it down though. It's a bit over. Let's take a little bit out. There we go. Now, I'm going to pour this dry sand over the top, trying to get it in the middle as much as possible. Because remember, I need to do this as exact the next time as I did this time. Try to get it exactly the same. Please take note of the other stuff that's going in. Tap, tap, tap. Right. Now the next thing I need to do is I need to pour 1 litre of water over the top of that. Now remember the purpose of this is a model of erosion. So we want to look at how the erosion works when the tray is flat. So let me see if I can do this without spilling water all over this desk. Oh, that looks dangerous to me, so I'm going to do it there. Remember, we've got to look at safety as well. Safety is not just about will someone get hurt, it's about will it ruin the experiment. So I'm going to fill it up to the top of this, which is exactly 1 litre. There we go, managed to do that without making a complete mess. I'm going to lift it up, and I'm going to pour it like this. See how it's flat? I'll make sure it's the same next time. Over the top, and I'll try to pour it at the same pace. Watch what happens with the erosion. Actually, probably better from the corner. I'll do the same thing next time. Look at what's happening to the sand. Look at where it's going. 1 litre, or 1 litre. Now just keep in mind, I deliberately make mistakes sometimes, so keep that in mind. There are some problems with that. Okay, that's our first one. I've had to change the camera angle a little bit this time because the angle blocked the camera when I was filming it from the back, but anyhow, that's not really changing the experiment. So, we've got the different angle this time. That's the condition we've changed. So this is the second trial. The first one is the first trial. So, when we're doing a scientific experiment, we do a thing called trials. And between each trial, we change one thing to test it. So, we're changing the angle. Everything else should be the same. I am deliberately making mistakes though, so remember that. There are things that I've changed which I shouldn't have changed. So watch what happens with the erosion now. Remember, this is not weathering, this is erosion. Erosion is where soil, in this case sand, is washed away and moved, or blown away, or moved in some other way, perhaps through people moving around or animals. I'd be thinking if we had some plants on the top of this, the roots would hold it together too. So what we're looking for is the difference, or are the differences, that occur when we observe the water going onto the pile of sand and rocks and stones and pebbles. So there we go. Look at the difference. Look at where the sand has gone, because that's what you're going to need to be able to report back in your scientific report.
If you've watched this video all the way to the end, then you've found it either interesting or useful. So please like and subscribe. It really helps me.